Questions you may have doubts in questions. Any doubts? Any doubt in any of the theory part, any of the concept? Highest more than 3 terms, Ashu, that's correct. Polynomial means more terms. Poly means many. See, if you go about the meaning of the word, poly means many, and this nomial means term. So there's only one term, it is called monomial. Okay? When there are 2 terms, it is called binomial. When there are 3 terms, it is called trinomial. So like that. So in general, there is no limit. So we call it, when there are many terms, we call it polynomial. So basically, binomial can also be said as a polynomial because it is having many terms, 2 terms, like that. So other than terms, then there was a degree, that is highest power of the variable. Yes, that should be not necessarily positive only. It is related to the previous topic only. Baba, I told, it is related to the previous topic only. Linear equations, then quadratic, and then further higher degree equations, we call them polynomials. Okay, let's start now. Let's see. So in general, we are going to talk about nth degree polynomial now. So again, it is a very mathematical session, and from the beginning only, you will get the big expressions. Yes, I already told about this. Yes, thank you, Annie. So this is general equation of nth degree or polynomial of x. Okay? So you are seeing big expressions here. So let me read one point, and then we shall discuss it. So it's written here. So let polynomial fx is a0 x power n, a1 x power n minus 1, a2 x power n minus 2, and so on up to an. So this is a polynomial of degree n. Let me put it in box. So this is a polynomial of degree n. Okay? a0 x power n plus a1 x power n minus 1 and so on. So here a0, a1, a2 up to an, they are called coefficients, right? They are called coefficients of those particular variables. X is the variable. So x power n, what is the coefficient of x power n? It is a0. Coefficient of x power n minus 1, it is a1. Coefficient of x power n minus 2, a2, and so on. Fine. Okay, now this is a polynomial. X is the only variable. I have discussed this last time also when we are discussing about all these equations and degrees and number of solutions or roots. So we are always talking about single variable equations. So they are single variables, but the highest power, whatever is the highest power, that makes a degree of the polynomial. So it says here, this a0, a1, a2, an are rational numbers, and n is a known negative integer. So this power must be a whole number, non-negative integer. Then the values of x for which fx becomes 0 are called roots of the equation. Right? So here root is also going to be identified. So what is the meaning of a root? So root means the value of x which will make this equation equal to 0. Ria, if you were not there in yesterday's class, you can continue now. If you don't wish to, then you can go through the last class first, and then you can see recording of this. Okay? So don't worry, it is connected only. This is continuation of the last class. So degree, we had discussed it in the first class. First class almost you have attended, na? The linear equation we started with. So there also we talked about polynomials. So degree, kisko bolte hain? What is the degree of polynomial? The highest power of the variable. See, variable is x here. So on each term we can see different powers of x, right? Here, this is a constant term, x power 0 is there. Then x power 1 will be there, x power 2 and so on. So highest power is x, highest power of x here is n. So this power of n, it must be non-negative integer or a whole number, right? So this is a non-negative integer. So different values of x which makes this equal to 0, they are called roots of the equation. Okay? And how many roots will be there? That is determined by this n. So if degree is n, then there will be n roots. Fine. So let's take some examples. It is given here. Highest power of x is called the degree of the equation. So all these things we have done already. We have done these things already. We are just repeating that, and there is going to be a lot of heavy questions today, and few conceptual parts are also there. So for example, this first equation, x power 4 minus 3x cube plus 4x square plus x plus 1. First tell me whether it is a polynomial or not. I am asking about this. Please answer in comments whether this first equation, is it a polynomial equation or not? Is it a polynomial part or not? Yes or no? Please write fast and see in the comments. Yes. How do you get to know whether it is polynomial or not? What is the criteria to check? Please confirm. What is the criteria to check? How do you get to know it is a polynomial? More than 2 terms is not compulsory, beta. I told you 2 terms bhi chalega. Yes, degree or basically power. So power of variable in each term must be a non-negative integer. I repeat, please listen carefully. The power of variable is x here, right? So power of variable should always be a non-negative integer. Non-negative integer, right? So here power is 4, 3, 2, 1, and this is 0. So 3, 2, 1, 0, all these powers are whole numbers. So that confirms it is a polynomial, right? And highest power is 4, that is called degree. Is it fine? Understanding? Suppose if I write something like this, x plus 1 upon x. Is it a polynomial? Yes or no? Yes, that's why I'm asking Aryan. Now this x plus 1 by x, is it a polynomial? It is not. Why? Because this x has a power of 1. It can be written like this, x power 1 plus x raised to power minus 1. Fine? The variable is x only. Terms I could have increased also, but it is not a polynomial because the power of the variable is not a whole number now. It is a negative integer. Fine? So power cannot be negative integer. Power has to be integer. Power has to be non-negative integer. That is whole number. Fine? So that confirms that the equation is a polynomial equation. Is it clear? Number of terms doesn't define that. Number of terms may be 2 only, 3, 4, 5, any number of terms can be there. But power must be a non-negative integer. Is it clear? Yes or no? Fine. So number of terms doesn't matter, but power of the variable in each term, that matters. Okay, good. So this is a polynomial of degree 4. Fine. So that's what is written here. So this is an equation with a degree 4. Wonderful. Same way. This is a polynomial, yes, of degree 5. So equation with degree 5. Same way, ax plus b equals to 0. This is called linear equation. We have already discussed that. Linear equation, kyun bola? Why it has been said as linear? Because the power is 1. So now power is 2. So it is called quadratic equation or degree 2 equation. And this is degree 3. So again, it is a polynomial of degree 3, or it is called as cubic equation. So all this was the basic part. Let's continue. So for degree n, fx is equal to 0 will have n roots, including real and imaginary both. Okay, that also we have already discussed. So this degree, this highest power, tells us about the total number of roots. Let me write total number of roots. Now nature of the roots can be anything. It may be real roots, it may be imaginary roots, it may be equal roots, it may be different roots, but total number of roots, whatever types of it may be, so that is given by this n. Fine. So degree n will have, for equation of degree n, this will have n roots, including real and imaginary both. Fine. Now next part, if R1, R2, R3, these are the roots of this polynomial. We are talking about the same fx. So there are n roots, right? We are assuming that R1, R2, R3 up to Rn, these are the n roots. So we discussed it last time also. If R1 is a root, that means x minus R1 must be a factor. Okay, na? Same way R2 is a root, then x minus R2 must be a factor, and so on. So like this. So then fx can be written as product of all these. Okay, can you point out any error in this? Can you point out any error in this? Is there something more to be added here? See, we are talking about the same fx. We are talking about the same fx. So fx is a0, x power n, a1, x power n minus 1, and so on. It is having degree n. So n roots, we assume n roots are R1, R2, R3 up to Rn. So if R1 is root, yes, thank you, Nakshatra, A. So the coefficient of x power n is a0 here. But if we multiply all these brackets, we are going to get coefficient of x power n as 1. So we are equating it with this fx at the top here. So a0 must be multiplied. So let me multiply it here. This a0 needs to be multiplied. Fine. Coefficients are not missing. Here coefficients have been written in terms of the roots. So as in the previous part, while discussing quadratic, we found out by equating the other coefficients, we got the relation between the coefficients and the roots. Today also we are going to get that. But at least the coefficient of x power n needs to be matched, right? So x power n ka coefficient, in this case, it is going to be 1. But in the actual equation, it was a0. So a0 also needs to be multiplied. Dobara batana last part. Okay, let's take a small example. I'm putting it here. What should I write? Okay, say there's an equation. I'm writing a quadratic part only. Let's say 2x square minus 5x plus 2. Okay, I've written this quadratic polynomial. It's a quadratic polynomial, fine. So it is a quadratic polynomial. So it will have 2 roots, yes or no? Yes, it is going to have 2 roots. So if I want to make it equal to 0, it is going to have 2 roots. Okay? So there will be 2 values of x which will make it equal to 0. So let the 2 roots are a and b, or alpha and beta. So if a and b or alpha and beta are the 2 roots, in that case, we have just discussed that x minus alpha will be a factor. That's what we have used here, right? So this can be written as equal to x minus alpha. X minus alpha is going to be a factor of this. Also x minus beta. Fine. Now, is it exactly equal? No. We need to take care of the coefficient of x square also. That is 2 here. So this 2 also must be put. So that was the thing. Yes, in order to equate the equations, so we need to match all the coefficients, and for that purpose, so x minus alpha, x minus beta are the factors, but their product will give me a coefficient of x square 1 only. So but on the left hand side, you can see coefficient of x square is 2. So we need to put this 2 here so that coefficients are matched. Fine. So same way, I have put this a0 here. So we discussed it yesterday also, so don't forget this highest coefficient, the leading coefficient. Okay, let's move further. There are many more properties. So this was the basic part we had already covered. So now what is the new thing we are going to get? So now we are going to get, by equating other coefficients, we are going to get the relationship between these roots of nth degree polynomial with the coefficients. And what are these results? So they will be here soon on the next slide, I guess. So let's read further a few more points. So again, some theory points. So have patience and see. If there's any doubt, yes, we are having our I-Quanta team members here, so they will certainly help you. So in an equation with real coefficients, imaginary roots occur in pairs. That also we discussed yesterday while discussing quadratic. So if there would be imaginary roots, they will occurring in pairs. That is p plus iota q is the root, then the other will be p minus iota q. Okay, we discussed it yesterday also. If one of the root is 2 plus root 3, then other will be 2 minus root 3. That is for irrational roots. And for imaginary roots, if one is 2 plus iota 3, then other will be 2 minus iota 3. Right? And we also discussed why this will happen, when this will happen. So this will happen when the coefficients are rational numbers, which is just the next point here. So in an equation with rational coefficients, irrational roots occur in pairs, or conjugate pairs also we call them. Or this will happen always when the coefficients are real numbers, right? Rational numbers are also real numbers. So imaginary roots are also going to occur in conjugate pairs, and irrational roots are also going to occur in conjugate pairs. So that is said in these 2 points. So example is given here, 3 plus root 4, then another one is 3 minus root 4. Same way 3 plus 4 iota, then another would be 3 minus 4 iota. Fine. Yes, this is conjugate only. We talked about it yesterday also. Let's move further. If the coefficient of an equation are all positive, that's an important point, good point. If the coefficients of an equation are all positive, like in this example, all coefficients are positive, fine. Then it says, then equation has no positive root. Then equation has no positive root. Let's see in this equation only. 3x power 4 plus x square plus 2x plus 1 equals to 0. Here we can see that all the coefficients are positive, right? This is positive 3, positive 1, positive 2 and positive 1. So, of course, it is a degree 4 equation, so there are going to be 4 values of x which will satisfy this. Can x be a positive number? Just think for that. I'm not saying to you to solve this. It won't be possible to solve it easily. But can x be a positive number? Divyansh, it's always in a plus iota b form. If root is imaginary, then other will also conjugate pair. That was the thing, Divyansh. So yes, answer here is no. How can you say no? Because if I take x to be a positive number, so that positive number raised to power 4 will remain positive. This is also going to remain a positive number. This is also going to remain a positive number. This is also going to remain a positive number. And sum of the 4 positive numbers cannot be equal to 0. Right? That confirms that equation has no positive roots. Right? We can't get it 0. Good. So as I said, this is a good point. Easy, but it's a good point. We should have these basic things in mind. Okay, now there's another important thing here. The common roots. So sometimes in exam we get direct questions. What are the common roots of two polynomials? Okay, two common roots. Sign changes when it goes to both sides. That will come there. Venkat, please wait. That will come in that Descartes rule of sign. So we will discuss about that also. So the common roots for this equation, fx equal to 0 and gx equal to 0, is obtained by fx minus gx equal to 0. Or we can say directly equating them. Right? So if there are two polynomials, fx and gx, so whether they have common roots or not, so how do we get to know? We just equate them, or we put their difference equal to 0. So with the condition that roots of fx minus gx equal to 0 also satisfy fx equal to 0 and gx equal to 0. See what we are going to get. So if we equate the two polynomials, we are going to get their intersection points, right? We are going to get the intersection points. Let's take an example here. Let's take a small example. Although we are going to cover some questions based on this. Suppose take two linear equations only. Let's say take two quadratic part. X square plus 2x plus 7. Okay, this is one quadratic polynomial. This is one quadratic polynomial, and other one is say x square plus x plus 11. So both of them are quadratic polynomials. Fine. Right? So both of them are different polynomials. So now our target is to find their common roots. See, this polynomial will have two roots for sure. This will also have two roots. Now roots are real or non-real, whatever it may be, but there are going to be two roots. So are they going to have any common roots? So how to get? We just need to equate them. Right? See, this was y equals this value, and this was also having y equals this value. So when we are equating them, it means we will be getting the values of x for which both are having equal y. So that's why I said that when we equate them, we are going to get the intersecting points. Intersecting points or intersection points. Right? We are going to get the values of x and y which satisfy both of them. But that intersection point lies on x-axis or not, that we need to see. Okay, if I equate them, what I'm going to get? X square will be cancelled. So this will be x equals 11 minus 7, that is 4. Yes, many of you are writing that. Okay, so now this is the intersection point. See, now at x is equal to 4, what is the value of y? Is it coming out to be 0? Let's check. So value of y would be how much? Put x in any of these two. So 4 square 16 plus 4, that is 20 plus 1, 31. So x 4 and y 31, that is their intersection point. Right? But is this a root? No. You know what is a root? Remember, we discussed yesterday also regarding quadratic. So whenever this graph of quadratic polynomial, which was parabola, wherever it intersects x-axis, that is called root. Right? Intersect x-axis means at this point y is going to be 0. Right? So whenever this y is equal to 0, that value of x is known as the root. But at this value of x, y is not becoming 0. Y is becoming 31. So there is no common root here. So what was this thing? It was just an intersection point or intersecting point. Fine. So that's how we need to check whether two polynomials have a common root or not. So first we will equate them. So fx equals gx. If there are two polynomials, we'll equate them and find the values of x, whatever will be there. And at those values of x, we need to check whether they become equal to 0 or not. There may not be any such values of x, then there are no common roots. There may be some values of x, so that is their number of common roots. Is it okay? We are going to do some questions also based on that. Okay, let's move further. I hope this is clear. So the common roots for equation fx0 and gx0 is obtained by fx minus gx equals 0 with the condition that roots of fx minus gx equals 0 also satisfy fx0 and gx0. Okay, so we have discussed it. So while solving questions, we will be using it also. Now let's move further to some more theory points. Properties of roots. So as I was telling you, so if there are n number of roots, R1, R2, R3, Rn are the roots, and these are the coefficients. So now we are going to discuss about the relationship between the roots and the coefficients. Okay? There are many points I know that perhaps I might look like rushing. Okay, मैं पुरानी slide दिखा देता हूँ आपको. Those of you who wish to take a screenshot or something, you can. Otherwise, you have an option of relooking the video also always. Okay, let's move further. So now we are going to discuss about the relation between roots and the coefficients, and let me just again connect it. Let me again connect it with your quadratic part which we did yesterday. So let me again check this slide. So ax square plus bx plus c, that was our quadratic part, and if the two roots are alpha and beta, so then we can write it as a times x minus alpha, x minus beta. right? We discussed slightly similar thing just before also. So by equating the other coefficients, we got the relation between the roots and the coefficient. So what was the roots? What was the result? Result was that sum of the roots, that is alpha plus beta was equal to how much? That was minus b by a. Remember, you know? And alpha into beta, that is product of the roots, that was c by a. Now extending this same logic, if I am looking for a cubic equation, ax cube bx square cx plus d equals to 0, if this is my polynomial of degree 3 or cubic polynomial, so it will be having 3 roots. Let the 3 roots are alpha, beta, gamma. Fine. So it will be equal to, it can be written in the similar way as a times x minus alpha, x minus beta, x minus gamma, and by expanding it, by multiplying them and equating the coefficients, again we are going to get the relationship between the roots and the coefficients. And what is going to be the root? Similar expressions. So how it would be? See, so first I'm adding all the roots. So here also, if I will be adding all the roots one at a time, alpha plus beta plus gamma, so it will be having same relation as the last time, that is minus b by a. Is it fine? I'm not showing you now by expanding. You can multiply and see it. I'm just giving you the hint. Just by multiplying and expanding them and equating the coefficients of x square, you will get this thing. So sum of the roots, taking one root at a time, it is going to be minus b by a. Exactly same thing as last time. Okay. Now the next thing is the greenest flag. Acha. Okay. See here. I was here. Okay. So taking one root at a time, it comes out with this part. Now again, sum of the roots multiplying two roots at a time. That means alpha into beta plus beta into gamma plus gamma into alpha. Okay, there were 3 roots only, so there were 3 combinations of multiplying 2 at a time, alpha into beta, alpha into gamma, beta into gamma. So sum of all these roots multiplying 2 roots at a time, that is going to be same as last time, c by a. Please take care about the sign. It was negative b by a, then positive c by a, and the final one more step would be there now. So multiplying all the 3 roots, that is product of the roots, you can say alpha, beta, gamma, it is going to be d by a. See, now this is positive d by a. Okay, so take care of this sign here. I hope you are understanding the pattern, right? I'm not expanding it because it will take more time and that's not required also. So just by going in the same way, we are going to get this thing. So sum of the roots taking 1 at a time, it's minus b by a. Sum of the roots taking 2 at a time, it comes out to be c by a. And product of all the 3 roots, it comes out to be d by a. Okay, before I move back to the last slide, can you extend this same logic for 4th degree polynomial? Let me write it here. Ax power 4 bx cube cx square plus d. And if 4 roots are, let's say r1, r2, r3, r4, let me write like that. So it must be equal to a times x minus r1, x minus r2, x minus r3 into x minus r4. Fine. My first question, please answer everyone. What will be r1 plus r2 plus r3 plus r4? Answer please. Answer please. Yes, exactly. It is minus b by a. As we did last time, exactly same thing. Okay, na? I'm not expanding it. I already told you. You can expand if you want to clarify. I'm not bluffing you. मैं धोखा नहीं दे रहा हूँ, right? So this is the exact thing. So sum of the roots taking one at a time, it is going to be minus b by a. And second part, if I'm taking two roots at a time, that means I'm multiplying two roots at a time. Can you figure out if I'm multiplying two roots together, so how many terms would be there now? Like r1, r2, r3 like that. How many terms would be there? There will be 6 terms. So r1 ke saath there would be 3 terms. r1, r2 plus r1, r3 plus r1, r4. Also there would be then r2, r3, r2, r4. And finally there would be r3, r4. So there would be 6 terms. And this sum is going to be equal to c by a, as many of you have already written. Yes, I can see that in comments. Good. So it will be c by a. And similarly, multiplying 3 roots at a time. So that is going to be how many terms? There will be 4 terms this time, and that is going to be negative d by a. Take a minute. This should be negative d by a. In the previous case, it was negative d by a. I missed that. I think no one of you pointed out that out. It is going to be negative. Its sign is going to be alternate, negative, positive, negative. In the last case, by mistake, I wrote positive. It is going to be negative. The same way here also, it is going to be negative. So multiplying 3 at a time, that means r1, r2, r3. I have left r4 here. Plus r1, r2, r4. This time I have left r3. Then r1, r3, r4. This time I have left r2. And finally r2, r3, r4. So there is going to be 4 terms, and that is going to be equal to negative d by a. So these signs are alternate, negative, positive, negative. Okay, last time I did that mistake. This should be negative. And finally, r1, r2, r3, r4, multiplying all the 4 roots together, this value is going to be how much? It is going to be positive sign, e by a. Okay? Okay, so I hope you have got the idea. Now when we are going to extend the same logic for the nth degree equation, we are going to get the following results. Here are they on your screen. So sum of the roots, taking one at a time, r1, r2, r3 and so on, it is minus a1 upon a0. So a0 was the coefficient, the leading coefficient, a1 was the second leading coefficient to x power n minus 1. Okay? This part. Yes, exactly. Plus minus यही चल रहा है. Alternate sign. So this is negative a1 by 0. Sum of the roots, sum of the product of the roots taken 2 roots at a time. So as we discussed last time, r1, r2, r2, r3 and so on. So this would be now with positive sign a2 by a0. Taking 3 roots at a time, it will be minus a3 by 0 and so on. So when we are multiplying all the roots, that is product of all the roots, so it is going to be minus 1 raised to power n. So it depends upon n, how many roots were there, whether this final term is going to be with a negative sign or positive sign. Fine. So that's going to be this part. Yes, fifth degree may that will be negative. Exactly, Vaibhav, that's correct. Rashna, what do you want to repeat? You can tag icon or something. They will certainly help you, and anyone else can also help you. Okay. Let's move further now. So we have discussed about the relationship between roots and the coefficients. So we extended the same idea which we discussed in quadratic as well. Okay, so let's move further. Now we are up to questions. Okay, all these things which we have discussed will be covered in the questions as well. So don't worry. Let's start with the first one. Try to answer it fast. Find the cubic equation whose roots are 2, -1 and 3. Radha, whatever is doubt, you can ask so that that can be clarified. By the way, so far we have not learned any hyphen, nothing. We have just extended the previous knowledge. Okay, answer please. Here's one answer. X cube minus 4x square plus x minus 6 equals 0. Aratrika says, let me write. X cube minus 4x square plus x minus 6. Okay, and in between I could show some other answers as well. Okay, most of you are saying same thing. In between I saw one more answer. That was basically these are the three roots. So we know that we can write the equation as x minus 2 into x plus 1 into x minus 3 equals to 0. See, when we are equating it to be 0, so the coefficient a, the leading coefficient, can be discarded also. Equation will be okay, right? There can be more equations as well by putting a here. So this is one of the equations, so which you are doing. So by multiplying, we can easily find the answer. We just need to multiply it, simplify, then we can get the answer. ठीक है ना? I hope there is no need to multiply. You all have already done that. So ठीक है, should we proceed further? Sir, यहाँ हम x cube का coefficient क्या लें, वो कैसे determine करें? हाँ, सही बात है. That's what I mentioned, Surajit. So when we are talking about equation, so in equation that coefficient can always be discarded. That's no issue. But when it is asking about cubic polynomial, let's say it may have said. Suppose question would have been कि fx is a polynomial. Fx is a cubic polynomial with these three roots. Fx is a cubic polynomial with roots. This 2, -1 and 3. See, this is the question. ठीक है? So fx is a cubic polynomial with roots 2, -1 and 3. So now question says find f of 1. Now everyone please tell the answer. Everyone please tell the answer. Fx is a cubic polynomial with roots 2, -1 and 3. So find f1. What will be f1? Ha, Tanish, that's true. That can also be done. Tanish, that can be done. अच्छा, वहाँ +6 आएगा क्या? You can multiply and see. हाँ, प्लस आएगा, ठीक है. I have not multiplied it. I have left it to you. So this is going to be our equation in the last case. But now I am asking this one. So if it is given that fx is a cubic polynomial, now that is the important term here. So with roots are 2, -1 and 3. Now we need to find f1. Yes, now answer will be cannot be determined. Now 4 is not the correct answer. Why? Because now I know that fx is certainly having x minus 2 as a factor, x plus 1 as a factor, x minus 3 as a factor. But what is the leading coefficient that needs to be taken care of? So let it be a. I do not know the value of a. So I want to find f1. So by replacing x with 1, so whatever will be the answer, that will be in terms of that leading coefficient which is unknown. That's why answer would be cannot be determined. But while talking of equation, that is fine. While talking of equation, that is fine, whatever you're getting. Is it okay? Are you getting the difference between equation and polynomial? For that purpose only I have shown you this. So when we are talking about a polynomial, so there can be many polynomial with same roots, but while we are talking of equations, we are equating it to 0. In that case, it is okay. If it is 2 here, 3 here, 4 here, that doesn't matter. Okay, let's move further now. Next question. A, B, C are the roots of the equation. And what is the value of 1 by A, 1 by B, 1 by C? Okay, before this question, let's do it together. Rahul पूछ रहे हैं why equation is okay. So please understand. If I say that x square plus 2x minus 3 equals 0. Suppose I say this, x square plus 2x minus 3 equals 0. Fine. So if I multiply whole equation by 2, then also it is going to remain 0. So 2x square plus 4x minus 6 is also going to be equal to 0. That doesn't make any difference. But if I'm talking only of this expression, then these two are different expressions. They are not same. It is double of this. If we call this as fx, then this is twice of fx, right? Then this is twice of fx. Or if I write as a different polynomial gx, then fx and gx are not same. But when I'm saying both are equal to 0, then doesn't make any difference. That's what we have just discussed. Okay, now coming to this next question, A, B, C are the roots of this equation, then we have to find this value. But before this, let me, most of you are getting answer by the way, -2. Excellent. Can you tell me in this case, what is the value of A plus B plus C? I'm talking this question now. So this is the equation given, cubic polynomial, cubic polynomial equation. So what is the value of A plus B plus C? Please tell me. That is sum of the roots. By coefficient we can see that, right? It is 4. Right? Negative times negative 4 by 1, that is 4. So if I take 2 at a time, that is AB plus BC plus CA. How much this would be? How much this would be? negative then positive. That is going to be 2 only, right? Coefficient of x cube is 1, so it will remain 2 by 1, that is 2 only. And if I multiply all 3 at a time, that is a, b, c, how much it will be? What will be the value of a, b, c? It's minus 1. Yes, we need to take care of sign. So negative, positive, negative. So negative of 1 now. Okay, so now this question was asking about 1 by a, 1 by b, 1 by c. 1 by a plus 1 by b plus 1 by c. We just need to simplify it, right? So taking LCM, we are going to get a, b, c in denominator. And at the numerator, we would be having product of 2 at a time. That is ab plus bc plus ca. Now we can just plug in these values. That is 2 upon minus 1. So that will give you the answer. Fine, that was just a basic part. I hope it is okay. मोहित बियानी क्या बोल रहे हैं? ठीक है. Oh, divide equation 3 by equation 2. Yes, that's what we are doing. Okay, before I move to next question, tell me a few more values here. So this was first thing, second, third, and this fourth one which we have found out. Okay, tell me one more thing. Can you tell me the value, let's say fifth part. Can you tell me the value of, what should I ask? Let's say, 1 minus a into 1 minus b into 1 minus c. Please be careful and answer this one. Can you find out this value? 1 minus a into 1 minus b into 1 minus c. Please answer fast. Okay, answer please. Okay, are 0. How you are getting 0? Let me check. I don't know whether that is right or not. How have you done it? Can you explain how have you done it? Most of you are saying 0 only. Okay. See, one way you are getting different answers as well. Shruti says 2, Vihana says 5. Otherwise, most of you are saying 0. Yes, open the bracket. Prerna suggests that open the brackets. Yes, by expanding, by opening the brackets, by multiplying the terms, so we can get our answer. Let's see what happens. So when this constant term is multiplied, it is going to be 1 only. If I'm going to take single of these alphabets, multiplied with 2 of the 1 ones, so it is going to be negative a, negative b, negative c. That is minus times a plus b plus c. Fine. And then with positive sign, I'm going to get ab plus bc plus ca. And finally, it will be negative abc. Please check whether I have expanded it correctly or not. Please check. Is it fine? Have I done any mistake in this? I hope there should not be many mistake. Signs are correct now. Minus, plus, minus. Okay, now we just need to plug in the values. We have already found all these values. So a plus b plus c was 4. So this is equal to 1 minus 4. Then a, b, b, c, c, their sum was 2. So plus 2. And finally a, b, c was negative 1. But that is with negative sign. So it will become positive. So positive 1. So 1 and 2, 3 and 1, 4 minus 4. 0 is the right answer. Good. Good, that's correct. But the important question now, please listen carefully. Is this the only way to answer this question? That means to find this first we need to determine these 3 values. Can we do something better? Excellent. Shruti is saying something. Yes, Shruti, that is good thing. We can directly put the value. Good. Many of you are saying that. See, that's what the thing for which I gave this question. So this cubic polynomial x cube minus 4x square plus 2x plus 1, it is a degree 3 polynomial with leading coefficient 1. Okay? And it is having 3 roots a, b and c. So this can be written as equal to x minus a, x minus b, x minus c. Yes or no? Yes, why not? Because leading coefficient is 1 only, so we don't need to put anything extra here. Fine. Now our required expression was 1 minus a, 1 minus b, 1 minus c. So what value of x should we put here so that it becomes 1 minus a, 1 minus b, 1 minus c? So we just need to put x equals 1. Fine. So just put x equals 1. So that will become 1 minus a, 1 minus b, 1 minus c. So putting 1 here and value of x as 1 here, that will be 1 cube minus 4 times 1 square plus 2 into 1 plus 1. So that's simply our answer. So which is 1 minus 4 plus 2 plus 1, that is 0. Is it understood? Okay, then quickly tell me one more if you are able to understand this. Let me write here, 6th part. What if 1 plus a, 1 plus b, 1 plus c is to be figured out? Please tell this answer also. 1 plus a into 1 plus b into 1 plus c. Rashna, that's why I have given more question. Rashna ji, please see it here again. This cubic polynomial had 3 roots a, b, c, so we know that x minus a is going to be a factor, x minus b as well, x minus c as well, and because the leading coefficient of x cube was 1 only, so we don't need to put anything extra here, right? Now this given expression is similar to the one we wanted to find out the value of, right? So 1 minus a, 1 minus b, 1 minus c. Here it was x minus a, x minus b, x minus c. So we just need to put the value of x as 1, so that it becomes 1 minus a, 1 minus b, 1 minus c, and that's what I have done here by putting x as 1. Now in this case, when I need to find 1 plus a, 1 plus b, 1 plus c, what we need to replace x by? X को क्या लिखना पड़ेगा? Most of you are, by the way, writing same answer, and that's really good. But in between, I can see some other answer as well. Some of you are saying 8, some of you are saying 6. Some of you are saying -6 also. Okay, let's check. Let's check. Can you tell me what should I replace x with in this expression? -1. Yes, I need to put x as -1. Let me do it here only, and I'm changing the color to make the things visible. Okay, so if I put x as -1, please see here, -1 minus a, right? -1 minus b, fine. -1 minus c. Minus क्यों put किया? Why I put -1? Because if I take minus common, it is going to be 1 plus a. This minus common, it is 1 plus b. Minus common, it is 1 plus c. So minus into minus makes it negative of the required expression. Are you getting it? So this is negative times 1 plus a, negative times 1 plus b, negative times 1 plus c. So if I'm multiplying all three, it is going to be negative into negative into negative. That is minus of the required expression. So basically, it is negative of 1 plus a into 1 plus b into 1 plus c. Yani ki if I put x equals -1 in this expression, I just need to cancel out this minus, or basically I need to put a minus sign there, right? I just need to multiply with -1. Let's see. So if I put -1 here, so answer is going to be negative of putting x equal to -1 here. So -1 ka cube is -1. -4 into -1 square, that will make it -4 only. 2 into -1 will be again -2, and +1 will remain +1. Fine, and whole this is being multiplied with minus to cover up this one. Okay, so -1 -4 is -5, -5 -2 is -7, -7 plus 1 is -6, and minus times -6 is equal to 6. So most of you are writing 6, that is the correct answer. It is not -6, it is not 8, the 6 is the right answer. Fine, otherwise as we did earlier, you can expand it and get the answer, that is also a way. If I expand it, what is going to get? What we are going to get? We are going to get similar expression with all positive terms. Basically, all terms will become positive. So one, any blunder? 1 plus 4. Is there any mistake somewhere? It should be 6 only. बाहर minus कैसे? बाहर minus इसकी वजह से है ना? If I put x equals -1, so minus times 1 plus a, minus times 1 plus b, minus times 1 plus c. So minus makes it negative of 1 plus a, 1 plus b, 1 plus c. So now to cover up this part, by putting x equals to -1 and multiplying minus, we will get the answer. So that's what we have done here. Okay, so if I'm going to expand it, what are going to be the values? Let's see. If I'm going to expand it, it is going to be the same thing. That is 1 plus a plus b plus c plus ab b c c a plus abc. We just need to put the values. Let's see. The values are a plus b plus c was 4, so 1 plus 4. 1 plus 4, AB BCCA was 2, so plus 2, and this ABC was -1. हाँ ठीक तो है ना? -1 will be cancelled, so that's 4 plus 2 is 6. That's the right answer. ठीक है? हाँ वो cancel हो जाएगा, right? I by mistake I thought कि कहीं वो positive तो नहीं है. ठीक है, fine. Is it okay? Is it clear? So both ways we have done it. So we can expand the brackets and then simplify, put the values, or otherwise we can make use of the roots part. There are going to be more questions. Wait. There are going to be more questions based on this. So it is not the last question. Let's move further now. Similar question. Find the given for the given equation. Find the sum of squares of roots and sum of cubes of the roots. Similar question. Please try this now. And yes, that I can see is a very good practice. Keep helping each other. If someone is having any doubt, if you can clear that, please do, because it's very difficult to see each and every comment here. And our eye contact team members are also there. They're also helping you in between. Okay, please answer this question now. For the given equation, find the sum of squares of the roots. Let's assume the roots are a, b, and c only. Okay, for simplicity, we can assume the roots to be a, b, c only. Gunjan is saying 17, the Kavya and Subhajit says 5. How we are going to get this? Any idea, Gunjan? We are getting different answers. 17, 5, 7. Can someone suggest how to go about it? How to proceed? Sum of squares of the roots. That means we want to find out a square plus b square plus c square here, right? That's what we want to find out, if a, b, c are the roots. Using identity, exactly. Thank you, Tathagat. So we need to use the identity. Do you know what is the identity for a square plus b square plus c square? Yes, we can use a plus b plus c whole square. It is equal to a square plus b square plus c square plus twice of ab plus bc plus ca. That's one of the identity, right? Yes, exactly. Negative नहीं है बेटा, वो हाँ ठीक है उल्टा हो गया ना कशिश, ठीक है, that's correct. So by seeing this equation, immediately we should be able to get a plus b plus c. How much? That is positive 3. Fine. AB plus BC plus CA, how much this would be? So negative, positive, so it will remain positive 2 only. And the third part, A into B into C, that would be negative of -1, that is +1. So these three things we should immediately get, right? So now using this thing here, we can find the value of a square plus b square plus c square. Let's plug in. So this is 3, so 3 square 9 equals this a square plus b square plus c square, and plus 2 times AB BC CA, which was 2, so 2 times 2 makes it 4. So the required answer is simply 9 minus 4, that is 5. Many of you got that. Good. Is it okay? Excellent. 5 is the right answer. Now in the next part, B part, we want to find sum of cubes of the roots. That means we want to find out a cube plus b cube plus c cube. Now what is the identity which can be used here? Kshitij says, sir, यही वाला part एक बार कहाँ गया पता नहीं. A plus b plus c 3 कैसे विनीत? अरे बाबा कैसी बातें कर रहे हो? Why are you forgetting this? A plus b plus c क्या बनेगा? Negative of negative 3 by 1 ना? That means it positive 3. We are just using those relations only here. Okay, Vineet? And here was one more comment I missed. That's Kshitij, यही वाला part एक बार समझा दीजिए please. यही part की हम बात कर रहे हैं. Okay, so a plus b plus c whole cube you can use here. What is a plus b plus c whole cube? That would be difficult, I guess. A cube plus b cube plus c cube. What further? See, here is an easy identity that you have done in 9th class NCERT. Let me write it. The identity is a cube plus b cube plus c cube minus 3abc. This is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. That is one of the identity you have done in your 9th class NCERT. NCERT 9th class. And I hope you have done that part also. When a plus b plus c equals to 0, isko hata do, a cube plus b cube plus c cube becomes equal to 3abc. By the way, in this case, a plus b plus c is not equal to 0. Yes, if you will cube both sides, then that can be done also. That's okay. But you will struck with many terms in between, Anurag. And you will be stuck in between with many terms. So that is the easiest way here. So we need to use this identity. Now in this identity, we need to find the value of a cube plus b cube plus c cube. You know what is abc. You know what is a plus b plus c. You have just found out a square plus b square plus c square. And you also know the value of this ab plus bc plus ca. Right? So by using this identity, we'll get the answer. Yes, school के बाद भी identities use में आ रही हैं. Exactly. I have said this many times. Mathematics till 10th level is must for everyone. And I think we discussed in some of the previous classes that in algebra part, your linear equation, then quadratic equation, then polynomial, and then series part also. So till that, it is must for everyone to do religiously, now without fail. Although it is mathematical equations and many things are there. After that, the functions, the maximum, minimum, that is the logical part. So if your brain allows you, you should go ahead, but at least that minimum part must be done certainly. Anyway, so now we can easily find the value. Please find the answer. Please find the answer. Okay, many of you are getting it 12. Pranav, that is the basic. We have done it. There is nothing new more you need to find. This identity we must need to know if we were not knowing it already. So I just revised it. Right now, remember it. Fine. So earlier we used this identity. That was a plus b plus c whole square, and now we have used this identity. Fine. Okay, so it's not that students don't like maths if they are not taught right. That may happen, but anyway, we can't blame others, na. If I want to learn something, I can't blame my teachers were not good, otherwise I would have studied. My school was not good, otherwise I would have studied. We can't blame others. Anyway, so let's calculate. Although many of you already calculated 12 as the answer. So still, let's put the values. So a cube plus b cube plus c cube we want to find out. That is going to be 3abc plus 3abc means 3 times 1, that is 3 plus a plus b plus c, which was 3 multiplied with a square plus b square plus c square, which we just found as 5, minus ab plus bc plus ca, which was 2. That's it. So this is our answer. 5 minus 2 is 3. 3 3s are 9. 9 plus 3 12. So 12 is the right answer. Good. Okay, let's move further now. Here is the next one. If the roots of this equation are 3 consecutive integers, then what is the smallest possible value of b? Please read carefully, think logically, and simplify. We are going to discuss identities. Don't worry, if someone of you are missing what are the identities, we will discuss them. Shashank is asking identities के अलावा कोई और method for cubes? No. It will be very difficult. Well, simple answer is no. We need to remember this identity to make the thing simpler. Okay, one answer I have got. Mimansha says 0, but Pranav says -1. Array. There's going to be only one answer. Either 0 or -1, or maybe none of them. Please recheck your answer. Chandru says -1. Vijay says again B -1. Okay, how to proceed? How to proceed? Can you suggest? How to proceed? It is given that the three roots are the 3 consecutive integers. Roots are 3 consecutive integers. How to start about this? How can we start about this? Any suggestion? Okay, a minus d, a plus d. One good thing here, Shubham. You know what is d here? D is 1 because there are 3 consecutive integers. So d to pakka 1 hi hai na? So Aryan is saying a plus 1, a plus 2. Better than that is yes, a minus 1, a and a plus 1. Yes, that would be better. So let's take the 3 roots as, in place of a, let me write alpha because a is already being used here. So I'm writing, yes, somebody wrote r. Let me take r. So the 3 roots are, let's say r minus 1, r and r plus 1. Fine. So these are three consecutive integers. Now, how to find the value of b? Remember, so this sum of the roots for this part and sum of the roots taking 2 at a time. In that term, this b will be involved. So basically, this negative positive. So this b is equal to, this b is going to be equal to multiplying 2 roots at a time, right? That means r minus 1 into r plus r into r plus 1, and finally multiplying these two, that is r minus 1 into r plus 1. So that is the part. Fine. So this is the value of b, and we want to find the smallest possible value of b. So basically, we want to find the smallest possible value of this expression, isn't it? Let's simplify this. So this comes out to be r square minus r. Let me write everything. R square minus r. This term is going to be r square plus r, and this is going to be r square minus 1. Now that is also an important identity. I hope you remember. So a minus b into a plus b, that is equal to a square minus b square. So using that identity, directly I can say r square minus 1. Now this negative r plus r will be cancelled and nothing else cancels. So r square, that is 3r square. So 3r square minus 1. We want to find the minimum possible value for this. Okay, so what can be minimum possible value for this? How did we get the value of r? I don't know the value of r. How did you find b? Anurag is asking. Anurag bhai, remember the relationship between the roots and the coefficients. Don't forget that. All these questions are based on that only. Sum of all the roots taking 1 at a time, that would have been minus times minus a upon 1. That is a. Or b कैसे मिलना था? Multiplying 2 roots at a time. That's what we have done. हाँ, तो yes, so if you want to minimize this, so r square to minimum 0 ही हो सकता है when we take r equals 0. So taking this term to be 0, so we are left with minus 1 as the minimum value. This is the minimum possible value for b. So the answer is option B. That is correct. ठीक है? हाँ, yes, अगर c पूछा होता, so then we would have taken product of all the three. अगर a पूछा होता, in that case we would have multiplied, added all the three. That's true. Is it okay? Okay, let's quickly move forward. There are many more things to cover. Okay, here I am. The number of common roots. Now this next part, common roots between these two equations. Please try to do this. I hope you remember. We just discussed the basic theory part initially. Now it's the time of application. Number of common roots between these two equations. Please solve. Preetham, 3r square minus 1 will be minimum when you take r equals 0. That's it. If you take anything else, the value of r, then 3r square minus 1 is going to be more than minus 1, isn't it? We wanted to find minimum value. Gunjan, you are right. R1 plus R2 plus R3 will be minus b by a. But we need to see what is b, what is a in the given equation. Yes, Shubham, you are right. In this case, we need to equate the two polynomial parts and find the value of x. And then also, don't forget, we need to check. We need to check whether at that value of x, this polynomial is becoming equal to 0 or not. Okay, so many of you are saying 2. Option C. Okay. I'm just giving 1 more minute so that others can also complete. Aditya says x equals 3 or 2. Okay. Yes, by equating them, you will get a quadratic equation, which you can simplify. Vijay says option B. Okay, let me check now. So by equating the two polynomials, what I'm going to get, x cube minus 6x square plus 11x minus 6. I need to equate it with this other polynomial, which is x cube minus x square minus 14x plus 24. Of course, x cube would be cancelled out. Minus 6x square taken on the right hand side, it will make it 6x square minus x square, that is 5x square. Okay. This positive 11x, when brought to this side, it will become negative, so that is minus 25x. And same way, minus 6 will become positive, so plus 30. That makes it equal to 0, which means 5 can be cancelled out throughout. So our quadratic equation is x square minus 5x plus 6 equals to 0. And that you can easily simplify. So minus 3 and 2 will be the factors, right? So x minus 3 into x minus 2 equals to 0, which means x equal to 3 at x and x equal to 2, that two polynomials will intersect. But as I said, we need to check whether it satisfies the equations or not, whether it makes equal to 0 or not. Let's see. So for that purpose, what we need to do, I just need to put these values back in any one of the equations, right? Any one of the equations. So let's, in which equation? Let's say the first one we put. If I put the value of x equal 3 in this first one, so what it is going to be? 3 cube minus 6 times 3 square plus 11 times 3 minus 6. We just need to check whether it is coming out to be 0 or not. So 3 cube is 27 minus 3 square 9 into 6 54 plus 11 into 3 is 33 minus 6. Okay, let me add the positive terms together. So 27 33 makes it 60 and 54 6 also makes it 60. This is 0, which means 3 is one of the common roots. Excellent. So 3 is there. Now we need to confirm for 2 also. Let's check. So if I put x equals to 2 in the again first equation, so 2 cube minus 6 times 2 square plus 11 times 2 minus 6. I need to see whether it comes out to be 0 or not. Let's see. 8 minus 4 into 6 is how much? 48 plus 22 minus 6. Okay, this time I don't think. So 8 plus 22, it is going to be 30. I have not done any mistake now. This was 24. Sorry. I made this mistake. This was 24. 2 square is 4, 4 into 6 is 24. So 8 plus 22 is 30 and 24 and 6 also added to 30. Okay, again it becomes 0. So this is also a common root. Fine. So we need to check. Yes, 24 tha. I did it knowingly to see whether you are vigilant or not. Good, you are alive. So 3 and 2 are the two roots. So question was number of common roots. Yes, of course, it is C, 2 roots. There are 2 common roots. Both are common roots. Yes, Gunjan, that is very important. Gunjan is asking, is it important to verify? Exactly. If you don't verify, remember when I was discussing about the theory part of this, that we need to equate them. At that time, I discussed when we are equating them. So the values of x which we are going to get, they tells us about the intersection points. Intersection points. All right. So at this value of x, their y is also same. That is the intersection point. Whether that intersection point lies on x-axis or not, that needs to be clarified. ठीक है ना? That needs to be clarified. So without that, it is not possible. Is it okay? ठीक है, अच्छी बात है. So आपको कुछ पुरानी यादें ताजा हुई. Anyway, okay, let's move forward now. Gunjan, I hope it is clear. Is it okay? Okay, ठीक है, you have mentioned that already. Good. Let's move further. Here's one more question based on the common roots. Please answer this again fast. The number of common roots between these two equations. It is not necessary. I think I read somewhere in between the comments. If one point is satisfying, the other will also satisfy. It is not. One equation is satisfying, the other equation don't need to be checked. Whatever values of x we are getting, all the values need to be checked. Okay? Don't be misled anywhere. Whatever values of x we are getting as intersection points, all those values need to be checked certainly. Okay, so I have started getting answers here. हाँ, ये एक अच्छी बात बोली. एक अच्छी बात बोली, because whole equation is positive. Kashish is saying that. That's good point. Because both equation is positive, there are no positive roots. There are no positive real roots. But negative roots can be there, na? Maybe negative roots, common roots, no? Isn't it? Negative roots may also be common. So we need to verify. Just by saying we can't say. Roots are not positive. Roots will be negative. Coefficients are all positive. That's how someone was saying. Okay, let me equate them. So if I equate, so I will get x cube plus 3x square plus 4x plus 5. This must be equal to x cube plus 2x square plus 7x plus 3. So x cube is going to be cancelled. 3x square, 2x square will make it x square. 4x, and here it was 7x, so that will make it minus 3x. And plus 5 and plus 3, that will be plus 2 equals to 0. So this is the quadratic equation left. And again, it can be factorized easily by splitting the middle term. So we get x minus 2 into x minus 1 equals 0. I hope it is fine. X square minus 2x minus 3 is fine. So we get the values of x as 1 or 2. Now we need to check by putting it back whether it satisfies or not. Now that doesn't satisfy, that can be easily seen, because by putting x equals to 1, we are going to get a positive number. By putting x equal to 2, also we are going to get positive number. Acha, somebody was saying roots are positive. These are not roots. I repeat, these are not roots. These are intersection points. These are not roots. These are intersection points. Now whether these are roots or not, for that purpose only we are putting them and checking whether it is a root or not. That's what we are checking. Okay, so that's how there are no common roots. So whenever we are equating the polynomials, let me repeat whole thing. So whenever we are equating the polynomials, what we are getting is intersection point. So we need to check that these intersection points, so these values of x, whether they are roots of the given equation or not. So because they are the common values which satisfy both of them, which are the common roots for both of them, which are the intersection point for both of them. That means by putting x equals to 1, see what you are going to get. Let me repeat. If I am going to put x equal to 1 in this one or in this expression, I am going to get the same values of y. That was the whole thing we started with by equating them. So this was y equals to first polynomial, y equals to second polynomial. We are equating them. That means at these values of x, that is 1 and 2, we are going to get same value of y. So now we need to see whether y comes out to be 0 or not. Right? That was the whole step. So that two-step process. First part, we are finding the intersection points, and at these values of x, we want to see whether y comes out to be 0 or not. So in this case, there are no common roots. So the number of common roots is 0. I hope there is no doubt over here now. Let's move further. समझ में आ रहा है? That's very good thing. Thank you. Yes, they were intersection point. Don't consider 1 and 2 as the roots. They may be, they may not be. That's what we have to check, whether they are roots or not. Okay. What if x is equal to some big digit number, then it will time consuming? Don't worry about that. See, whether the question is time consuming, some big numbers or some small numbers, that is a common question for everyone. So don't bother about that, please. Okay. Let's move further. Somebody was talking about this Descartes' rule of sign. So that is a very simple rule. This rule is something like that. Let me take an example. We'll talk with the example. So if we are having a polynomial, let's say px or fx, whatever, px लिख लेते हैं. If px is x power 4 minus 3x cube plus maybe 2x square minus x plus 1. Okay, let's assume this is our px. Okay, now this Descartes' rule of sign, it says that number of sign changes when all the coefficients are written in order, so the number of sign changes in the coefficients, sign changes means, sign changes का मतलब क्या है कि here the coefficient is positive, here the coefficient is negative, right? So the coefficient is changing from positive to negative. So there is a sign change, right? There is again a sign change, there is again a sign change, there is again a sign change. So the number of sign changes tells us about the maximum possible number of positive real roots. I repeat. Let's make a table here. So number of positive real roots, and then negative real roots. and then if roots are not real, then roots would be imaginary. Okay? So for this polynomial of this format, so roots are going to be positive roots, real roots, or negative real roots, or the roots may be imaginary. That is the thing going to happen. Fine. So now this Descartes rule of sign tells us according to the sign change, depending on the sign change. So px में हमने देखा, in this px number of sign changes are 4, right? So number of sign changes here are 4. Let me write here sign changes. Sign changes. So number of sign changes in px is 4. Is that part okay? Number of sign changes. So here sign was positive, coefficient, sign of coefficient was positive. Here sign of coefficient was negative. So positive, negative. There is a sign change. So one sign change is here. From -3 to +2. So negative to positive. Again sign change is here. From positive to negative. Again one more sign change is here. And from negative to positive. Again one more sign change is here. So there are 4 sign changes. So this Descartes rule of sign says if there are 4 sign changes in px, in that case maximum possible number of positive real roots can be 4. I repeat, this is a maximum. It is not exact value. Okay, it is not exact value, it is a maximum possible value. So if 4 real roots are there, so this was a polynomial of degree 4, so roots 4 ही होने वाले थे ना. So that means a negative must be 0 and imaginary must also be 0. Is it fine? That is a comment of Descartes. We are not going over explanation of it कि ऐसा क्यों है, why so. We are not going to discuss that. We are just seeing what is this rule. And sometimes it is helpful in solving questions. Sometimes, of course, not always. It is not going to tell what are the roots, but it will just tell this part. Okay, let me repeat now. So a number of sign changes, which is 4 in this case, it tells us about the maximum number of positive real roots. Now one thing is there next. This is the maximum possible number of roots. If this is not the case, then what is the next thing which Descartes says? Descartes says if maximum number of real roots, positive real roots are 4, so if it is not 4, then it will be 2 less than this. It will be 2 less than this. Now 2 less than this, it means it can be 2. There are 2 real roots, 2 positive real roots. So in that case, other roots can be something else. Chicken, it can be other than something else. Okay, what should I say now? I think let's wait it here. Let's wait here at this point. This other part I will discuss later. Till this point, is it okay? I'm repeating it again. Shruti, we have just said that. The number of sign changes in the coefficients, when all the coefficients are written in order, that tells us about the maximum possible number of positive real roots. Provided these sign changes we are checking in px, the given polynomial. This is the maximum value. Okay? Now the next step. इसके बाद अभी बात में करते हैं. First listen here. Now the next step. Now we need to see, Descartes says, let's talk about p of minus x. And check the same thing. A number of sign changes in p of minus x. What is the case? So that will tell us about the maximum number of negative real roots possible. That will tell us the maximum possible number of negative real roots. Let's check here. So if I find the value of p minus x, let me write it here. So p of minus x, what it is going to be? So if I replace x by minus x, it is going to be x power 4 only. And this term will become positive this time because negative x ka cube will be negative. So this is plus 3x cube now. And this will remain same, 2x square. And this will become positive because I'm replacing x by minus x. And this plus 1 will remain same. Okay, so now this is p of minus x. So what is the number of sign changes in p of minus x? There is no sign change, 0. Positive. Here again, no sign change, 0. No sign change, 0. No sign change, 0. Is it okay? Aditya was asking why this 0. Baba, total number of roots are going to be 4, degree 4, right? Degree 4. So degree 4 to roots 4. So if positive real roots are 4, then others would have to be 0. Now this p of minus x, in this case, there are no sign changes. That means now Descartes says maximum possible number of negative real roots for this polynomial has to be 0. So 0 maximum hai. Alright? So pakka 0 hi hai ye to. That means certainly this is the case. Certainly this earlier one is the case. So if this is 0 and this is 4, what else can happen? Can anything else happen? There's one more possibility. See here. So either we are having 4 positive roots, no negative roots, no imaginary roots. That's one of the case possible. The other case possible can be, as I was writing earlier, that this is the maximum possible number of real roots. Now the other possible values can be 2 less than this. So the other possible case can be 2 positive real roots. This is certainly 0. Then 2 has to be imaginary. Or there can be one more case possible. Again, subtract 2. So if 0 positive real roots, this is 0 for sure because that was maximum value. Then all 4 are imaginary roots. So these are the 3 possible scenarios for this particular polynomial px. That is the inference of this Descartes rule of sign. So thus there are 2 terms, there are 2 properties. I'm just repeating that. So it tells us number of sign changes in px. That tells us about the maximum number of positive real roots. And second part, number of sign changes in p of minus x tells us about the maximum number of negative real roots. Okay, so depending upon that, we can estimate the number of positive, negative, and imaginary roots of a polynomial. Shruti, you're asking only first one is applicable. No, Shruti, all 3 cases are there. See, unless we solve it to find the roots, we don't know what actually they are. So Descartes is solving that part only, and it is telling us either this polynomial is going to have all positive real roots, or if 2 positive real roots, then 2 imaginary, or no positive real root and no negative real root, of course, then all 4 imaginary. So what is the case? That we need to solve. So the next possible value will always be negative 2 in all the cases. Abhi 0 se to negative hona nahi tha na, otherwise here also we have to do it. So these are the 3 possible scenarios. Now what is the actual scenario? That is not determined by Descartes. Descartes doesn't tell what are the roots. It only tells about the estimated value of number of roots. So these are the 2 properties which we have to use. Number of sign changes in px and number of sign changes in p of minus x. Is it fine? We can't find the values. I'm not going to find the values of x. No, I'm not going to solve it. See, solving a polynomial is not easy part ever. That's not an easy part. And we are not going to do that. That's not required also. We just need to find out Can it have negative real roots? Can it have positive real roots? So that's what is estimated by Descartes, and this is the conclusion according to this Descartes rule of sign. Okay. So what can we conclude certainly about this polynomial using this Descartes rule of sign? That this polynomial cannot have negative real root. It cannot have negative real root for sure. Question is, can we solve something related to this question? Okay, these are types of questions. Let me see. We'll see further. This theory part is covered, I guess. Is it okay? We have just discussed these two things. So number of sign changes in Px tells us about the maximum possible number of positive real roots, and number of sign changes in P of minus x tells us about the maximum possible number of negative real roots. That's it. Okay, let's move further. Let's see some of the questions. Here's one of the question. Please solve it. By the way, I have not seen any or many questions based on this previous part in CAT, but it is a property which has been taught since ages. So that's why we just discussed that. In some places, see directly questions based on that maybe there, may not be there, but sometimes while solving a question we can use that property. That are the roots going to be positive only or negative only or what? Okay, na? Now please solve this question. Consider the pair of equations and then find the value of x minus y. Quickly, we need to reach up to certain indices also. Okay, I got one answer by Sai Ganesh. He says 8. Okay. Anshita also says 8. Pranav says 8 or minus 7. Minus 7 is not there in the options, by the way. Pranav, please recheck. There is 8 only, yes. That's fine. 8 or minus 1, both were possible, you meant to say. And as per options, it must be 8 then. Fine. Okay, how to solve it? How to solve it? What can be done? Any suggestions here? Any hints? Thank you, Anshita. Yes. Okay, let's see it here now. So many of you are getting the right answer. That's very good. So Anshita has given a nice suggestion. Just add the two equations. See, we want to find the value of x minus y. If I just add the two equations, what is going to happen? Let's see. X square plus y square minus xy minus xy. That will make it minus 2xy. Then this minus x and plus y. That is going to be the left hand side. I have just added the two equations. And this is going to be equal to this 22 plus 34, which is nothing but 56. Fine. Okay. So after that, this x square plus y square minus 2xy, this is our algebraic identity of x minus y whole square. Another identity being used here. So this is x minus y whole square. And if I take minus common here, this term is also x minus y, right? And from these two terms, I can take out x minus y common. It is x minus y into x minus y minus 1. Right? So x minus y is what we want to find out, and it is given that x is more than y, which means x minus y must be positive. So negative option, as somebody was writing, that is not possible. X minus y is going to be positive. So let me replace it by something, maybe n. So this is n into n minus 1. N is the value of x minus y. I'll just replace it so as to be free from any confusion. So it is n into n minus 1. It is equal to 56. And what do I know? That n is a positive number. Of course, we just need to write 56 as a product of two consecutive integers. So it is 8 into 7, and n is equal to 8. Fine. So that was an easy question. We were to just figure it out that we should add these two, right? Okay, let's move further to the next question fast. If the roots of this equation are real, which of the following must hold true? It's a very easy question. Don't be deceived by the appearance. Very easy question. Please solve it fast. Just CAT asks easy questions. But most of the students get baffled by the appearance of the question. Appearance by the mathematical appearance of the question. Answer please. See, it is just a quadratic equation, isn't it? X square, x, it's a quadratic equation. And we want that the roots must be real. Roots of this equation are real. Sanskriti has given the answer, option A. Okay. Okay, many of you, Chinmay also, Preeti, Shaurya. Good, good, let's see. So this is a quadratic equation and we want roots to be real. Do you remember what was the condition for a quadratic equation's roots to be real? What was the condition? What was the condition, please tell me? By the way, all of you are giving right answer. A is the right answer. I just solved it before this class, I was seeing it, and I generally don't prefer to write I try to do the questions mentally only. Condition was d is greater than or equal to 0, right? Not only greater than, it can be equal to 0 also. So discriminant must be greater than or equal to 0 for the roots of a quadratic equation to be real. And discriminant क्या होता है? It is b square minus 4ac. So b square means square of the coefficient of x, that is 2 into b square plus c square whole square. That is b square minus 4 into a into c. That means a square plus b square into b square plus c square. Now this term we want to be greater than or equal to 0. So certainly we can take out b square plus c square common. 4 also can be taken out common. So it is 4 times b square plus c square. Now what we are left with is b square plus c square here. This 4 we have already taken out common. So we are left with a square plus b square. With negative sign, that makes it negative a square, negative b square. That's it. So this must be greater than or equal to 0. This b square is cancelled. So we are left with 4 times b square plus c square into this c square minus a square to be greater than or equal to 0. Fine. That is the final expression we are having. Now 4 कहाँ से आया? Sir, do you know that ax square plus bx plus c, this is equal to 0? It's a quadratic polynomial. So its root will be real if discriminant, that is b square minus 4ac, is greater than or equal to 0. यहाँ से 4 आया. Okay? So we need to see what is b, what is c, what is a. Accordingly, I have written it, and this is the final expression we are getting. Now we want it to be greater than or equal to 0. 4 is never going to be less than 0. It is always positive. It's okay. B square plus c square can be minimum 0. It is never going to be negative, right? 0 plus 0, minimum it can be 0. So that doesn't create any problem. So basically this c square minus a square should also be either 0 or positive. That means this term, c square minus a square, it should be greater than or equal to 0, which means c square should be greater than or equal to a square. So this first option is the right answer. Clear? Although many of you have already got it correctly, that's very nice. Let's move further now to the next question. Okay, again question based on quadratic only, and this time we are finding minimum value. Remember yesterday we discussed about to find the maximum value and minimum value of a quadratic polynomial. So now please answer this. P and Q are the roots of this quadratic. What is the minimum possible value of p square plus q square? Yes, Shaurya, that's correct. 4 times b square plus c square is always positive. It can be 0 also, Shaurya, if both b and c are 0 in case. Five, 6, 5, okay, minus alpha. We are getting different answers here. Okay, let's see here. So p and q are the roots of this equation. What is the minimum possible value of p square plus q square? See, what do we know about p and q? So can you tell me the value of p plus q? How much it will be? Please write in the comments. What is the value of p plus q? That is sum of the roots. It will be alpha minus 2. Yes or no? Yes, minus b by a. So a is 1 here and b is negative of alpha by 2. Alpha minus 2. So this is going to be alpha minus 2. Good. And what is going to be value of p multiplied with q? That is going to be negative alpha, negative 1. Right? That is c by a. Okay. We wanted to find the value of p square plus q square. So now again we are making use of identity. So p square plus q square is going to be p plus q whole square minus 2 times p into q. Isn't it? Is this point clear to everyone? Is p square plus q square is going to be p plus q whole square minus 2 times p into q. Fine. Just let's plug in the values. So p plus q whole square will be alpha minus 2 whole square. Right? And 2 times pq, that is twice of this with negative sign. So negative will make it positive. So it is positive twice of alpha plus 1. It is fine? Okay. Okay. So let's simplify this. We are going to get alpha square. Here we are going to get minus 4 alpha plus 2 alpha will make it minus 2 alpha. Here we are going to get plus 4 and plus 2 will make it plus 6. So that is the final expression, isn't it? Alpha square minus 2 alpha plus 6. Till this point, is it okay? So p square plus q square, whose value we want to find out minimum, is coming out to be a quadratic expression. It is alpha square minus 2 alpha plus 6. So basically question is to find the minimum value of this quadratic polynomial. How to find that? Remember? Yesterday we discussed it in the end. So what can be done? It is going to have its minimum value. It is going to be upward parabola. It is going to be upward parabola, and it will have its minimum value at that vertex point, symmetric point. Yes, by completing the square is also one of the ways. Yes, both things are there. Okay, so if I complete the square, it is going to be alpha minus 1 whole square because it will consume alpha square and minus 2. So it will be plus 5. So at alpha equals to 1, this value, minimum value is 5. That's the right answer. Good. We talked about it in the end yesterday. So by completing the square, we are getting both the things at one go. Okay. Let me tell you one more value. Let me tell you one more method, one more way. Completing the square is always the best. There's no harm in that. Otherwise, we had already discussed this is going to be upward parabola because of the coefficient, leading coefficient being positive. Now it is going to be a minimum at which value? That is the midpoint of the roots, which was minus b by 2a. ठीक है ना? So minus b by 2a we can find out from here. So alpha is equal to minus b by 2a, which means negative of negative 2 by a is 1, which means at 2a, sorry, 2 into 1, that is at alpha equals to 1. So by putting alpha equal to 1, we'll get the minimum value as 5. That's one of the ways. Yes, differentiation is also one of the ways. So now let's understand one more thing. Let's understand one more thing. If I take alpha common from both these expressions, it is going to be alpha into alpha minus 2. I'm examining same expression. Alpha taking common, so it is alpha minus 2. Highest one-shot differentiation can be used. Those who know differentiation, that can be used here. There's no issue in that. So I'm telling one more way now. If I take alpha common, it is alpha minus 2 plus 6. Fine. Now see, we had discussed that this graph is symmetrical about this vertex line. Right, the vertical line passing from the vertex. So that vertex is at minus b by 2a. That is one thing. If I don't remember this, or if I don't know this even, then what can be done? See, we know that at all these points which are equidistant from this vertex point, the value of y are going to be same. Right, value of y are going to be same. So the vertex point is x-coordinate is going to lie between middle of that. So in this case, if I put alpha equals to 0, then the expression is going to be 6. Or if I am going to put alpha equals 2, then also the expression is going to be 6. Are you going to get that? Are you understanding that? Let me repeat. If I put alpha is equal to 0 or alpha is equal to 2, the value of the expression is same. That means 0 and 2 are the two equidistant points here. 0 and 2 are the two equidistant points here. Rashna ji, please see, if I put alpha equal to 0, value is going to be what? It is 6. If I'm going to put alpha equals to 2, then also value is 6. So what does it mean? It means that 0 and 2 are the values of alpha which are equidistant from that middle value. That means that middle value at which we are going to get the minimum expression, that is simply alpha is equal to 1. Okay? So that is alternate to remember this alpha equals to minus b by 2a. If you can remember this, it is fine. If you don't know, then it's a simple thing. Okay, let's move further now to the next question. By the way, this is also old CAT question. This is also previous year's CAT question. Harsh, I have just said that 0 and 2 are the two values of alpha which are symmetrically placed with that midpoint. So that midpoint lies exactly between them, that is alpha equals 1. That's it. So answer is 5, yes, answer is 5. So minimum value which we were to find out, that answer is 5. So we have just seen that different ways how we can go about it. So first we found out the value of p square plus q square, which was a quadratic expression. So we could have completed the square, that was the best way. We could have used that alpha minus b by 2a, it is going to be minimum. So that was another way. And now we have taken the common part and we have seen the two symmetrically placed values. So accordingly I found when it is going to be minimum, and differentiation using calculus was also of course one of the ways. Okay, let's move further. This is also previous question CAT, but I think let's do it together. I'm not giving you time. Let's solve it together. It says the number of quadratic equations with the leading coefficient 1, which are unchanged by squaring their roots. What does it mean? It means if initial roots were alpha beta, and if we square the roots, that is alpha square beta square, equation doesn't change. Equation doesn't change. So how many number of such quadratic equations with the leading coefficient 1 can be there? So that's what we need to see here. Okay, just think, if roots will remain same, then there's not going to be any change. Can you suggest any such roots which when even squared, they remain same? What can be the pair of roots? What can be such pair of roots which upon even squared remain same? 1, 1, excellent. So 1, 1 is one possible pair, because even after squaring, 1 square will be 1, 1 square will be 1, the roots will remain same. That is one particular case. Good. Anything else? 1, 0 is also possible case. 1, 0. If one root is 1, other is 0. So on squaring, 1 will remain 1, 0 will remain 0. So that is another possible set of roots that will make another second equation. 0, 0 is also one of the case. Good. So 0, 0 will also work, because on squaring, the roots will remain same, 0, 0. Minus 1 will not work. Somebody wrote minus 1 also. Minus 1 won't work because minus 1 the square will become positive, no? Okay. Now these three were very easy to figure out. But the tricky part is, here is one more case. The tricky part is, here is one more case. 1 minus 1 won't work. Diksha and others, somebody wrote minus 1. Minus 1 ka square will become plus 1. So that won't satisfy. So these three are very easy cases. So you can easily figure it out. Now there's one more possibility. Now listen carefully. It may happen. Right now what we have done, the alpha ka square is equal to alpha. Right? Beta ka square equal to beta. That's what we have done right now. Right? That's what we have done right now. But there's one more thing possible. Mehak ji abhi bhi nahi maan rahi hai. Mehak beta minus 1 won't work na. Minus 1 ka square is not minus 1. Okay? Okay, now see here, what I'm telling, be careful please. So till now what we have done, algebraically we have just done let alpha be equal to alpha square. If alpha equal to alpha square, it means alpha square minus alpha equals 0, which means alpha into alpha minus 1 equals 0, which means alpha is 0 or 1. Isn't it? So far we have found this. Now there is another possibility that alpha is equal to beta square and beta is equal to alpha square. Is it not? Let me repeat. That may also be possible that alpha equals beta square and beta equals alpha square. That is also a possibility that we haven't explored yet. Is it okay? Yes, that will lead to imaginary roots. That's you are right, love. So that will lead to imaginary roots. Let's see how. So I hope everyone agrees with this part. So this part is still remaining. So far, the values which we have written, just by seeing the numbers, we have tried to do that only. That alpha becomes equal to alpha square. That's how we have written this. But this is also a situation possible when alpha becomes equal to beta square and beta is equal to alpha square. Let's see what happens algebraically here. So if beta is alpha square, let's put it here. So I'm going to get alpha is equal to alpha power 4. Fine. Fine. Okay. So again, rearranging it, we will get alpha times alpha cube minus 1 equals to 0. Is it not? Yes. Okay. Imaginary roots CAT के पेपर में आती हैं क्या? It has. I told you this is also previous CAT question. So previously it has appeared. Nowadays we don't find any questions based on imaginary roots generally. But this is a previous CAT question. Many years ago this has appeared. Anyway, this doesn't involve many specifically focus on that imaginary roots, but it involves imaginary roots. Let's see how it is going to be. So it is alpha 4 minus alpha equals 0. Taking alpha common, it is alpha times alpha q minus 1. Fine. Now, do you know what is alpha q minus 1? Alpha cube minus 1 can be factorized. Now this is another factorization. So x cube minus 1, yeah, 1 cube basically, yeah, x cube minus y cube, let's say. So it is equal to x minus y into x square plus xy plus y square. So that algebraic identity we can use it here. Okay, let's see. So it comes out to be alpha into alpha minus 1 into alpha square plus alpha plus 1 equals to 0. So either alpha equal to 0, which we already got, or alpha minus 1 equal to 0, that is alpha is 1, that also we have got. And the third case is alpha square plus alpha plus 1 equals to 0. So this is the fourth case. So this equation led to both roots are 1, that means x minus 1 into x minus 1 or x minus 1 whole square. X minus 1 whole square, right? That was the equation. This is equal to 0. It was x into x minus 1. X into x minus 1 equals to 0. Here we were having x into x, that is x square equals to 0. Now this fourth case tells us this part, that is x square plus x plus 1 equals to 0. So x is such a number so that x square plus x plus 1 comes out to be 0. That is the fourth equation, right? I'm not expanding it. If you will find its solution, you will find the imaginary roots. This leads to imaginary roots. And what are the imaginary roots that you can certainly find out by using that quadratic formula or something. So, but anyhow, this is the fourth equation which satisfies this given condition. So answer to this question was 4. There are 4 equations. X minus 1 whole square equal to 0, or x into x minus 1 equals to 0, x square equals to 0, and the fourth one, x square plus x plus 1 equals to 0. Fine? Yes, it is cube root of unity, exactly. So those who are familiar with imaginary numbers, so that's perfectly right. So this is cube root of unity here. And those who are not, so don't worry, we want to just find the equation. Okay, let's move further. Chakkar mat lao bhai. Preetam, it's okay, it's okay. Last case clear nahi hua. It is very clear from this part. Now see it again. Just this is the sufficient part. When we are doing it here, so we are going to get this part. Alpha into alpha minus 1 into alpha square plus alpha plus 1 equals to 0. Till this part, I hope this is fine. There should not be any doubt. We have just equated the roots, right? Alpha equals beta square and beta equals alpha square. That's what we have equated here, and that's how we got these things. So alpha equals to 0, we have already taken that. Alpha equals to 1, we have already considered that. Now the final part was this, that alpha square plus alpha plus 1 becomes equal to 0. Right? So alpha is the root, and the equation must be x square plus x plus 1 equal to 0. So alpha and beta both satisfy this. That was the thing. So this value of alpha here is known as cube root of unity. It is an imaginary number. That's what many of students are writing. So anyhow, even if you are finding it little tricky, so don't bother. This was the important part here, to use the algebraic identity x cube minus y cube. So that was the important part, and there will be many questions based on this also in exam. Okay, don't bother about it. Let's move to the next question, and it is again similar question which we had done earlier. I think we can skip this question for now. You can take a screenshot if you wish. You can solve it later. Okay, you can solve it later on your own. I'm skipping it right now. It's a similar question which we had done earlier. So ABC are the roots or solutions of this equation. We have to find this value. Of course, you can find out a plus b plus c, a, b, b, c, c, a, and abc, and then substitute to find the answer. Riya beta, x square plus x plus 1 equals to 0. Can you find out roots of this quadratic equation? Please check, and then you can easily find. You know, using quadratic formula, you can find the roots now. To find out the roots, you will get to know. Purposefully, I didn't solve it because that is going to give you complicated roots, imaginary roots. Anyway, acha, you got the answer. Okay, those who found the answer to this question, fine. I'm not discussing it. This is a similar question. Let's move further now. This is a good question. Again, a previous CAT question. Please try to answer this one. Please try to answer this one. Okay, those who have solved the last question is nice. Now please answer this one. And after this, directly we shall move to the third analysis part. We'll discuss something about that. It seems that everyone is solving the last question. Please solve this question which is on your screen now. Okay, one answer I'm getting from Kavya. She says 1. Okay. Tathagat ji also says 1. Suprajit says, यहाँ D का value, 2 values आ रहा है, 0 and 1. ऐसा कैसे? Okay, how to proceed? Can anyone suggest? Any suggestions? How to go about it? I'm getting many answers by many of you. I think at least 5-6 students have answered already. How to go about it? Please tell me. Any suggestions? We just need to equate the coefficients. We can take in values of x. Yes, exactly, Subhajit. So what value can we start with? If I take x equals 1, this coefficient of a will become 0. Coefficient of b will become 0. Coefficient of c will become 0. We will be left with only d, isn't it? So at x equals 1, that's perfectly fine. At x equals 1, left hand side is 1 cube, that is 1. And in right hand side, this a term is 0, b term is 0, c term is 0, it is only d. So we got to know the value of d. d equals 1. That's the first part, isn't it? Next what? At x equals 2. This time, let's say I want to figure out the value of c. So by putting x equals to 2, these first two terms, a and b terms, can be made 0. So at x equal to 2, this 2 cube is 8. And this is going to be 0 plus c times 2 minus 1, that is c plus d. So c plus d comes out to be 8, isn't it? So what is the value of c then? Because d, we have already figured out it is 1, so c must be 7. Similarly, we can find the value of a and b as well. So by putting x equals 3, we can find the value of b now. So at x equals 3, if I put, so x equal to 3 will make it 3 cube 27. That should be equal to this a term would be 0 because x equal to 3 would make it 0. But these terms will remain. By putting x equals 3, so 3 minus 1, 2, 3 minus 2, 1. So 2 times b will be 2b plus, I'm taking x to be 3, so 3 minus 1, again it is 2, so 2c plus d. We know already the value of c and d, let's put. So c is 7, so 7 to the 14, 14 plus 1, 15. 15 when subtracted from 27. 27 minus 15 is 12, so b comes out to be 6. Right, b comes out to be 6. Okay, now to find the value of a, we can put any other value. Let's take 0 only, okay, let's go by that. If I take at x equal to 0, so this a is 0. So by taking a 0, x 0, 0, 0, 0, minus 1, minus 2, minus 3 makes it minus 6a. So minus 6a. We have taken x as 0, so it is minus 1 into minus, so it is positive 2b. We have taken x to be 0, so it is minus c plus d. You know all the values b, c and d, so substitute that and find the value of a also. So if I put value of b as 6, that makes it 12. So 12 minus 7, that is 5. 5 plus 1, that is 6. So 6a equals 6, that means a equals 1. Yes, we are almost done. So we were to find the value of a plus b plus c plus d, just add them. So 1 plus 7, 8, and 8 plus 7, 15. 15 is the right answer, and I can see many of you have got it. Fine. Okay, let's move further. And I'm directly jumping to, okay, let's do this part also. This is a good question. These are called special equations now. A square minus a minus 1, 0, find the value of a power 8 plus 1 by 8. It's an easy question. Can you try this? Can you find the answer? These types of questions are very frequently found in specifically government exams. And I have seen that many people remember the formula shortcuts for these things. But its basic algebraic identities are the simple reason to solve it, simple way to solve it. So try to answer this one first. Okay, I think we can solve it together. Maybe some of you have already started to solve it. Can we find the value of a from this quadratic equation and then substitute there? Will that be a good approach? I don't think so. By the way, I'm getting answer here. Harsh is saying 2, Ashu ji कहती हैं 15. जो भी हैं कहती हैं कि कहते हैं. No, that is not a good idea to find the value of a and then substitute a power 8, right? That won't be a good idea. So what we can do, let's see. So this a square minus a minus 1 equals 0. If I divide throughout by a, I repeat, if I divide throughout by a, I'm going to get a minus 1 upon a is also equal to 0, right? So which means a minus 1 upon a equals 1. Now that is our starting point. So a minus 1 upon a is given to us, and we have to find the value of a power 8 plus 1 upon 8. It is very easy now. Just square it. Just square it. And I hope all of you know that a plus b whole square, it is equal to a square 2ab b square, and a minus b whole square, if I do, it is a square minus 2ab b square, right? So just using that identity, how y divided by a to make it in this format, so that I don't need to find the value of a now. See, now what is going to happen, Aditya? If I just square it, what I'm going to get? A square plus 1 by a square, that is 1 plus a square, minus 2 into a into b, right? So minus 2 into a into 1 upon a. That is going to be minus 2 only, and it is equal to 1, which means the value of a square plus 1 by a square comes out to be 1 plus 2, that is 3. Is this point clear? Right? Now following the similar steps 2 more times. Again squaring it. I will get a power 4 plus 1 upon a power 4 plus 2 into this, that is 2 only, equal to 9. So 9 minus 2 will make this equal to 7. And in the final step, again same way, squaring again, a power 8 plus 1 upon a power 8 will be 7 square, that minus 2. So 49 minus 2, so 47 is the right answer. Okay? I told you, this is a very famous part, and many people use direct formula, shortcuts and all. So if you have that much storage in your brain's hard disk, you can. I don't prefer to remember things. So it's basic part. So the starting tricky part was that only. Convert this is in this format. So now we can easily square and simplify. Okay, yes, you forgot now, Vijay, that's what I'm saying. Okay, let's move further now. Now, as I said, I'm quickly jumping to, again, it's a good question. Good question. Can you answer this one? Nahi, chutti nahi, Akshat. Akshat, we need to wait for at least 5-10 more minutes. Just 2-3 more things we have to discuss. So these are good questions. That's why I can't skip them. These are different variety questions. Okay, how to solve this? Let's do it together. I'm not giving you time. Let's do it together. So 1 plus x square plus x cube is given 0. Again, it is not practical to find the value of x and then find the do it. So how to do it? First, can you tell me how many terms are there in this expression? In this expression whose value we want to find out, how many terms are there? Don't worry. I'm just saying, going to take 5-10 more minutes. Yes, Aditya, that's correct. There are total 2009 terms because x power 1, x power 2, x power 3 up to x power 2008. The 2008 terms are containing x, and there is one also. Total 2009 terms are there. And now, in this given expression, we had 4 terms, 1x, x square, x cube. So this value is given equal to 0, and we want to find the value of this expression. These types of questions also have been part of CAT repeatedly. This type of things also have been part of the exam repeatedly. So how to go about it? Okay, let's see here. Let's do it together. So accept this one, leave this one together, leave this one separate. And the remaining 2008 terms, if I make a group of 4 terms each, that is first group of 4 terms, x square, x cube, x power 4. Same way, next 4 group would be x power 5, x power 6, 7, and 8. And so on, right? That's how we can make a group of 4 terms together. If I take x common from here, yes, exactly, Nashatra, that's perfectly fine. So if I take x common from this, I'm going to left with the same expression which was equal to 0. 1 plus x square plus x cube. It is 0. Same way, if I'm going to take x power 5 common from here, again I'm going to left with 1 plus x square plus x cube, which was equal to 0. So same is going to happen in all further terms, right? So answer is clearly, this is 0, 0, 0, 0. Answer is finally 1. Right? So seemingly a heavy question is very simple question. Is it okay? Good. Okay, let me see what lies ahead. I'm leaving this. This is an easier one. Again, easier one. By the way, these are coming on your screen. You can solve them later, right? Not right now. Let's move further. This is again easier question. Previous CAT question. This is also previous CAT question. Easy. Yes. Let's come to this indices, surds, and their properties. And this is very easy part. This is very easy part. First, we just need to understand what is the meaning of this indices and surds. So, indices we call the powers of the numbers, right? Powers of the numbers. Say when we say, let's say 2 raised to power 10. All of you know that it means that multiplying 2 10 times, 2 into 2 into 2 into 2, total 10 times we are multiplying. There are 10 terms. There is a shorter way to write like this. And if you are having 2 power 9, it means 2 multiplied with each other, total 9 times. Total 9 times 2 is being multiplied. So if I divide 2 power 10 with 2 power 9, what is going to be the answer? Yes, last question answer 1 tha beta. Aishani, yes, that's correct. Jafar, it is finished. I'm just going to discuss few things and 1 or 2 questions. That's it. It is going to be 2, right? Because from these 10 powers, 9 powers are cancelled, and a common factor, only 2 is remaining. So in general, if I'm having, let's say, a power m upon a power n, the answer is going to be how much? Answer is going to be how much? It is a power m upon a power n. It is a raised to power m minus n. That's it. ठीक है ना? It's basic thing, simple thing. If you remember it, then it may be difficult. You may forget. But if you understand the basic terminology, it's not a difficult part. There's nothing to be remembered. ठीक है ना? Okay, one more thing. What about a power 0? Sometimes we remember it is equal to 1. है ना? But what it is, in place of n, if I put m only, so a power m upon a power m, that is going to be 1. That's how this a power 0 equals 1. So these are some of the basic identities. One more thing. If I ask you, okay, let me write it here. Again, I'm starting with the example only. 2 power 3 whole power 2. Can you tell me the value, please? 2 power 3 whole square. What will be the value? 2 power 3 whole square. This was 8 and 8 square 64, right? So it is 2 power 6, right? It is 2 power 6. Yes or no? Right? It is not 3 plus 2. Yes, somebody got 32 also. That happens when we remember the things. It is not 2 power 5. It is not 2 power 5. It is 2 power 6. See, that's what I'm saying. Ki understand the basics. Your basics must be clear, then there will never be any error. It is not 3 plus 2. This is not equal to 2 power 3 plus 2. It is equal to 2 power 3 multiplied by 2. How so? See, 2 power 3 means 2 is multiplied with each other, total 3 times. Total 3 2's are there, right? And this whole square means this bracket is multiplied with itself. Total 2 such brackets are there. So this first bracket had 3 2's. The second bracket also has 3 2's. So total 6 2's are there. So it is 2 power 6, which is 64. ठीक है? So don't mug up the things. अगर आप चीजों का रट्टा मारोगे तो भूल जाओगे, and it will become burdensome. But if you understand the basics, then there's no difficulty at all. Is it clear? Okay, one more last thing here, which I would like to discuss. 2 power 3 power 2. How much it is? 2 power 3 power 2. Yes, now it is 2 raised to power 9. This is not 2 raised to power 6, Ankita. It is not 2 power 6. See, this 2 is the power of 3. It is not power of 2 cube. In earlier case, this 2 was power of 2 cube. So 2 cube was being multiplied 2 times. But here, this 3's power is 2. So 3 is being multiplied with 3 itself. So it is actually 2 power 9, which is 512. Yes, bracket की वजह से. Bracket की वजह से. Okay? ठीक है, these are some of the very basic things about indices. And what is surd? Surd means when the powers are fractional numbers. When the powers are fractional numbers, then we call them surds. But properties are same. Properties are same. For example, let me take a case here. Root 2, that is actually 2 raised to the power 1 by 2. It is 2 power 1 by 2. So root 2 plus root 2 equals to root n. Find the value of n. That's a quick question for all of you. Please answer fast. Root 2 plus root 2 equals root n. What is the value of n? Yes, it's very basic. That's what I'm saying. Just 2 minutes, Jafar. I'm going to finish. We'll just do one question after this from a previous CAT paper. Vedanti says 2, Archie says 8, Subrajit says 8, Faiz also says 2. So 2 or 8. अरे बाबा सोच के बताओ ना. 2 कैसे हो सकता है? It can't be 2 for sure. Root 2 plus root 2 won't be root 2 only. So n can't be 2. 8 is the right answer. Yes, root 8. That's correct. N is equal to 8. See, root 2 plus root 2, that means 2 root 2. Now 2 root 2 is equal to root 8. If we take this 2 inside the root, it will become 2 square. So 2 square is 4 into 2, 8. So this n comes out to be 8. Okay, so don't do any such mistake here. Okay, I'm just going to discuss. These are some of the properties. You can take a screenshot, or otherwise you can do that later also. These are the basic properties. And let me skip this one for now. Yes, we will just end with this question. This is the last question for the day. So which among the following is the largest? How to do this now? This is the last question for the day. How to identify the largest among them? See, CAT still asks questions like this involving certain indices. This may be considered as part of numbers. Right now we have included it in this algebra part. So how to simplify this? Yash says LCM. Yes, LCM of whole powers. See, basically when powers are same, then we can identify the base numbers. But, okay, try to figure out. Mimansha says third one. That is 4 power 1 by 4. Mimansha ji, if you see it clearly, 2 power 1 by 2 and 4 power 1 by 4, they are same numbers. So 3 can't be the answer. Okay, let's do it. See, many of you are suggesting taking the LCM of powers, so but basically making the powers same. So this is 2 power 1 by 2. I'm rewriting them. 2 power 1 by 2, 3 power 1 by 3, 4 power 1 by 4, 6 power 1 by 6, and 12 power 1 by 12. So those who are doubtful what others are saying, so it's very easy thing. If their powers had been same, we could have easily compared. Or if the base numbers had been same, then we could have easily compared. But right now both things are different. So now to make something same, we can try to make the powers same. Now powers are fractional numbers, these are surds here. So let's try to make the denominator of the power same. And 12 is certainly their LCM. So if I want to write this first number, having a power with the denominator 12, so it must be written as 6 by 12. This 1 by 2 can be written as 6 by 12. Same way this can be written as 3 power 4 by 12, 4 power 3 by 12, 6 power 2 by 12, and 12 power 1 by 12. Is it okay? I'll just use that same LCM part only. And now the next part is very easy. So 1 by 12 is the common power among all, so that can be discarded. So beside that, we are having 2 power 6, whole number is 2 power 1 by 12. Same way this is 3 power 4, whole number is 2 power 1 by 12. And so on, 4 cube, 6 square, and 12. So now we just need to calculate these bracketed values and we can very easily find the answer. Of course, many of you have already done that. So 2 power 6 is how much? This is 64. 3 power 4 is 81. 4 cube is again 64. 6 square is 36. And 12 is 12 only. So we were to find out the largest, and it is quite obvious from all these values that 81 power 1 by 12 is certainly the largest. So answer is 3 power 1 by 3. If it had been asked the smallest, what would have been the smallest case? Of course, we can see it is 12. That is 12 power 1 by 12, right? And CAT has also asked question like that. He arranged them in increasing order or decreasing order. So that can also be done. ठीक है ना? Can be multiple LCM. I missed that. Anyway, so we can arrange them in order also, increasing order, decreasing order. Okay? So we shall end it here. So we have tried to cover all the parts. Of course, there is no limit to number of questions. We can go on solving more and more questions, but we have covered all the basic theory part. So we discussed about linear equations. We have discussed about quadratic equations. We have discussed about polynomials. We have discussed about certain indices also. And in between, we did some tricky part also, maximum, minimum of quadratic, that also we had covered. So now it's up to you to solve questions based on that, right? So you will be getting some assignments, some practice sessions, application sessions. There will be a lot of questions. So now after this, the next topic in algebra would be about your sequence and series, as I told you, the different type of sequences, progressions. And then after the functions, modulars, and all. Okay, so that's all for today. And thank you for your patience. And I'm so sorry that I extended the time. Thank you. Thanks a lot, everyone. So if there is any doubt, something, some comments, some feedbacks you can share, you are free from my side now. Good night. Thank you. Okay, so I'm ending this live now, live session. Hare Krishna, Abhishek. Thank you everyone. Akshat, what's your favorite topic? Are you asking me or someone else? If you're asking me, my favorite topic is geometry. I like geometry the most. Although it's most tricky part also, but still. Okay, Shubh Ratri. Aishani is asking root 2 plus root 2 root 2 कैसे हुआ? अरे भैया x plus x will be equal to 2x ना? What's the doubt? Yes, thanks Harsh. You can take root 2 common. Okay, good night.